Ladies and gentlemen, I want to welcome you all to It's Rainmaking Time. This is Kim Greenhouse. It's always a pleasure to interview people that are groundbreakers, that are doing remarkable work in the world, who have a huge difference to make. And I want you to know that our guest, George Swanson, has been on several times. We did a show with him back in 2012 that was one of the most exciting shows I think I've ever done, and I've interviewed remarkable people in every field imaginable. And I want you all to go back and listen to that, not only to this show, to that show as foundation. It's called Living, Breathing Buildings. It was done June 12th. It aired 2012. Then last year, we did a show with him last May on the health benefits of building with non-toxic materials. That was done on May 19th. And I was having a conversation with George. I have been part of managing a project for a friend that had to redo the internal paint of her home. And she had and has a very, very beautiful, huge bird named Katie. And I knew that if this paint was not true non-toxic paint, this bird wouldn't make it. You can't put animals in a building of any kind with new paint. The fumes last for years. So anyway, when we were talking, one of the things he started to talk to me about was heating and cooling, and how the ancient ways of heating and cooling, how buildings were optimized in the ancient times, and how the buildings of today do the opposite. Not only they degrade over time. When I listened to him on that call, I was so fascinated with what he told me. I said, we have to do an entire show about this. So he is the owner of Swanson and Associates, and he helps people bring in biological buildings, bring them, whether they're commercial facilities or residential facilities. He's probably one of the few whole systems experts in biological, in other words, non-toxic building and building materials. He is also the author of a book called Breathing Walls, a biological approach to healthy building envelope design and construction, which, after I have been through different parts of it, even with my lack of experience, every single school, every single homeowner, every single person that wants to build needs to have this as a primer. It's several hundred pages, the details of which are so critical it will transform your understanding of buildings and building materials. It gives me great pleasure to welcome George Swanson back to It's Rainmaking Time. Thanks for being here. Welcome to the show.
And thanks for the invite. Yeah, I'm really happy we get to focus on all these things related to the, internal thermodynamics of our own body and how that relates to the building envelope, and why and how our modern buildings are not in any way enhancing our health, our respiration, and our capacity for holding and distributing heat and cool throughout our bodies, and how the modern heating and cooling systems are the opposite of what we actually need in our basically heating our bones and cooling our bones, and not our tissue and our soft, envelope to our bones. So, yeah, to dive real deep into it, and I did reread the sections that I gave you as well, because I know there's a lot of kind of obscure scientific language in there, but it really
it's very, very scientific. But I'm sorry to cut in here, but I want to tell the public we are focusing on pages 40 to 51, 240 to 254, and 255 to 257. in his book, The Breathing Walls, who, by the way, I didn't say also the other people that were involved. Orem Miller and Wayne Fetter were also involved in that project. Okay, go ahead, because we're going to get detailed, because there's certain baseline information you must explain to the public that needs more flushing out. So let's go ahead and start with high thermal, or just thermal mass. Do you want to start there?
Sure. Yeah. Thermal mass is the ability of a material to hold and distribute heat or cool over time. And it turns out modern buildings with, 2x4 studs can't do that. So what we've done, we've become dependent on what we call air conditioning and air heating. And both of those are the opposite of what our body needs. For deep, long-term health, we need radiant heat, which is sun, fire, or hot water, and radiant cool, which is only cold water. But we're building envelopes around ourselves that can't handle that at all. In other words, we just try to resist heat and cold coming through a building. And of course, now we're sealing up our buildings super tight, making them extremely dangerous inside, just to think we're keeping heat or cool, in our building. Well, we're not. What's happening is the building envelope, if it can't breathe, if it can't dehydrate itself properly, it's bleeding internally. And that's the definition of mold, which our buildings are inundated with now as we tighten them up tighter and tighter all the time. So it comes down to the real old common sense of what we call outsolation combined with interior thermal mass. That's why the straw clay, rammed earth, and those types of buildings have worked so well for so many centuries. So this whole thin wall phenomena is really, not more than a few hundred years old. Well, even then, sensible people were building like double stone wall with air gaps between that dehydrated everything. Really just pure common sense. And we have so little of that now, but it relates directly to how we store, distribute, and maintain our own biological temperatures. And then, in other words, if we can store our heat and cool deep into our bone mass, we can walk in and out of the buildings and not catch a cold. In other words, we're internally balancing, and our blood only flows uphill at certain temperatures. What's called, as soon as we get a few degrees off between our tissue and bone temperature, it's called hypothermia. First, we go into complete brain fog, and we all have felt this around air conditioning. It should be, thermal mass conditioning, not air conditioning. The comfort level has almost very little to do with the temperature of the air. It's the temperature of our own bone mass that we should be dealing with. And building envelope that can handle that typically has deep thermal mass on the interior of the building with massive outsolation, meaning our hard-earned BTUs from either heating or cooling, and ideally that's all radiant, sucking directly into the thermal mass of the wall, floor, and ceiling, and take 8 to 12 hours to re-radiate for free after
Can you
we turn
repeat
off
that?
our heat
Can
and
you
cool.
repeat that? I'm sorry to interrupt you, but I don't know if you're on a VoIP system or not, but are you calling in from a cell phone?
Sure. Uh-huh.
Okay. I want you to repeat the last part of what you said. Can you
Sure.
remember the last part of what you said?
Yeah. About the thermal mass in our bones
Yes.
redistributing. Yes, throughout our
Yes.
body. Right. Yeah. Basically, the skeletal system of an average human being has a capacity of 3.5 hours of thermal storage. That means when we're heated by the sun, fire, or hot water, or cooled by cold water flowing over some rocks 30 feet away from us even, once that's into your bones, that can take a half hour, like standing in front of an ice cold rock wall here in Austin. We go down to Barton Creek, 100-degree day, the air between your nose and the rock wall with the cold water flowing is 100 degrees. You stand there, first 5-10 minutes, you feel nothing, then your bones start to tingle. And then after just a few more minutes of standing there, you can pivot on your heel, walk away, and feel like you're in heaven for 3.5 hours while that cools redistributes through all the tissues of your body and arteries and veins and makes the blood the right temperature to flow up to your brain. Because brain fog is the first big telltale of how poorly our modern heating and cooling is working. I think we've all felt it in front of AC over extended amounts of time, where we often in building biology, the two main ways to think of heat and cool distribution is, convection or radiant. And there's also, other divisions in there. But those, one is sending out heat and cool in a short wave through the air, convection, throwing hot or cold in a ductwork and blowing it out into a room. That is penetrating only into your tissue. And if you're 4 degrees off between your tissue and your bones for 20 minutes, that's called hypothermia. Every resource in your body turns off to get those two temperatures balanced because blood doesn't flow uphill at the wrong temperature. You're starving your brain. It medically is criminal, and it is. In Europe, for over 60 years, it's been illegal in schools, hospitals, or nursing homes to throw hot or cold air on the human body. It's all done with radiant, long wave. Now, it helps if you
George,
have building. Yeah.
Sorry to interrupt you here. I lived in Berlin.
Uh-huh.
And where I lived, there was radiant heat. It wasn't like
Correct.
anything I had experienced before. I was never sick. And I didn't feel these sudden changes in temperature. I
Right.
wasn't, how regular heat can dry you out? I didn't
Yes,
feel
yes.
any of that. It was
Yeah.
remarkable. And until you've experienced it, you don't know. Anyway, go
That's
ahead.
right. Yeah, and what we do here in Austin, we're real fortunate. We have these real clear water springs that, bubble from the center of town that are preserved really well, that flow over these outcroppings of rocks all summer long at 110 degrees. You go down there, you feel nothing but uncomfortable until you stand 30, 40 feet away from that wall for at least 10 to 15 minutes till the radiant long wave coming off that rock wall penetrates through your tissue into your bones. And that's why, after 15, 20 minutes, you can turn around, walk away, feel like you're in heaven for 3.5 hours. So that's the radiant cool side, and that's the least understood. And walls that can, hold radiant cool like that are not drywall 2x4s and hardy board. It doesn't work. It doesn't work at all. That kind of wall only has 10 or 15 minutes of thermal storage, and then you got to keep replacing the heat and cool. It's called cranking up your AC at 110 degrees. We understand that really well here in Austin. On the heat side of it, the example is even easier to demonstrate. You can go sit in a car at minus 10 degrees with the sun directly coming through the windshield. Measure the temperature between your nose and the windshield. It's minus 10, and you feel fantastic. The long rays of the sun are cutting straight through the air, straight through your tissue into your bone mass. That's proper heating and cooling. And we should have building envelopes that promote that.
There seems to be a human perception, a confusion in the area of perception, because most of us would say, oh, the temperature is X, therefore I'm hot, or therefore I'm cold. There's a psychological relationship with temperature only, but not radiative heat transfer, because we don't have that reference point. See what I'm saying?
That's right. Your body does. Right. Yeah. Luckily, if you're able to ignore whatever that little temperature reading was on the thermostat, you're better off. Your body knows. You know, I mean, it's ridiculous what we're doing. We're thinking some little measuring thing has more perception than the thousands of nerve endings in our body. You know this, you know, and your body's screaming for you to do it, because when you don't, in just, 20 minutes, you're into hypothermia. Hypothermia, over time is death.
But when you talk about hypothermia, when you talk about, sorry, here, because I don't see you on here, we're just in the audio side, so
Sure.
you don't see me trying to communicate with you in the public. When you talk about hypothermia, you do understand that 9 out of 10 people will say this does not apply to day to day. This is fine if you're in the Arctic. It's fine if you're in Newfoundland, or if you're in a really cold Nova Scotia, Canada, blah, blah, blah. It doesn't apply in certain places. So they're not going to be able to receive what you're saying when you speak of hypothermia in the context of building structures and materials, and you talk about this science. So
Sure.
can I want to ask you about 4 questions that are all interrelated based on pages 40 to 51. Did you want to say something else about what you were?
Only that, that again, when the beginning of hypothermia is, brain fog. Everybody's experienced that, in an enclosed space, with no natural ventilation, with AC going. Most people have already experienced that. That's the beginning of dying, actually. But, in other words, resources in your body are turning off, this whole brain fog phenomena. They have to. They got to get these two temperatures balanced for blood to flow uphill properly to your brain. It's pure physics, chemistry, and biology. And why isn't this taught? Right. Yeah, we won't talk about that.
Yeah, the whole book. So I want to go through boom, 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 boom with you to bring some reference points that are all progressed into this contextual and whole systems understanding.
Sure.
Very much like gold standards, quote, gold standards are created in many industries, which often survive way too long, because a lot of times you end up finding out that there's flaws in these gold standards. You find it out in medicine, traditional medicine. You find it out in research. You find it out in peer review. I did a whole piece with Gavin Menzies and Dr. Tim Ball on peer review. You all should listen to if you want to hear how the supposed gold standard for veracity and authenticity, what is the inner workings of that? You may think differently about it. But even in your business, George, there seems to be some type of a deceptive standard that has continued and been sustained and propped up a very long time with regard to something called R value. Talk about that.
Right.
Explain what it is.
Yeah, R value is just the pure resistance of a material to transfer heat or cold. So, in other words, blocking, the exterior cold or the exterior heat coming into the building. And that's a very, very deceptive term, because, basically they just measure the R value, or the resistance value of like pink insulation under perfect conditions, 72 degrees at 50 or 40% humidity, when you don't even need it. The minute it takes on moisture from a much larger gradient of temperature between the outside and inside, that R value begins to disappear because damp things conduct. They also conduct EMFs. We'll talk about that later, just how bad it is inside the cavity of a little 2x4 wall in severe heat or cold climates. They're wet all the time, rotting the building out, forming mold from just about from day one. And the tighter you seal it, the worse it gets. So R value is a very, very deceptive term. It was actually made up by Dow Chemical to sell their pink insulation, which luckily is in disfavor now. People finally get it. You spray that stuff with water, put it on your desk, and for 2 weeks it's still wet. And you put that in your wall. Natural materials like cotton and wool and even rock wool, a fluffed up, basalt rock and iron ore combination, it will all dehydrate in just a couple of hours. So things like rock wool have basically taken over the market, but only in the last couple of years, where people simply open their walls and see all the moisture in the black mold. And it's going on in mass. And, all of us built with it for so long because we were deceived by this R value. In other words, there was a way to give a big number to that pink insulation if you made up your own test, and it passed it real well. But it's a multi-billion-dollar fraud. And, luckily a few lawsuits, more and more lawsuits are coming through. And, people know that the companies, lawyers are bigger than your lawyers, and most people lose. But that moisture is caused by the nature of the materials in these cavities. So even in the 2x4 cavity, we can put at least rock wool because it gets rid of its moisture so much more rapidly and has this phenomena of being able to convert moisture to vapor. And my book goes really deep into this. It's the jugular vein. If you can convert moisture to vapor and then have all the layers of whatever your wall is made out of conductive to letting that vapor pass through, that cavity will stay dry. And those advertised insulative R values will actually exist if you could get the moisture back out in a systematic, scientific kind of way. But we're not doing it, because we're not teaching this to people. We're just teaching the R value. Well, obviously on a regular 2x4 building, 10 to 15% of the area is solid wood studs that are R1. So you take 15% at R1 and then the rest of it at their R value that only exists under perfect dry medium temperatures when you don't even need it. In other words, it's performing way, way under what's advertised. So these thermal mass buildings defy all of that by holding, hard-earned BTUs from whatever source inside the building, ideally radiant sources, because they'll penetrate, all the soft surfaces, and store that directly into the mass of the wall, and then redistribute it for, anywhere from 6 to 12 hours for free, 500 years from now, perfectly. And that's the buildings you were living in Germany. This is been taught in Germany on a PhD level for over 70 years. And for 50 years, it's been mandatory for every architect and engineers of all fields have to take 2 to 3 years training. And everyone knows those, Northern and Central European architects can all be sued if somebody gets sick in their buildings. If they had this training. In America, zero training, right?
George, I want to talk to you
Zero
about. I want to talk to you for the audience because there's many different types of people listening. There are people that are living in existing structures that they don't own. Okay,
Uh-huh.
so a lot of people may feel helpless what they can do. Then there are people that are living in homes or buildings that they already purchased, right? They're like
Yep.
done deals. And then there's people that want to build infrastructure, have the financing to do it, and are going to do it. And then there's them that's listening. They're about
Uh-huh.
to build. Okay.
Correct.
So
Yes.
in the same way that dowsers, let's say water dowsers had friction over the last 100 years working with geologists because the geologists were unfamiliar with the fact that a really good dowser could find primary water, could find water where the geologists couldn't, and there was friction about that or a kind of internal
Yeah.
politics.
Uh-huh.
I am sure that there is a kind of politics with architects and contractors about using this building, in other words, building structures and putting them together in the way that breathing walls articulates as possible for people that are building for the future. Do you agree with me on that?
Oh, yes, yes, a huge resistance because, the gold standard we have was formed after World War One when all buildings were done with these skinny walls. Right. We had this huge pent up desire from the war, for massive housing and, these gigantic subdivisions were built, starting main ones, in the New York and New Jersey area and then spreading to California. And so that became, we had two, three, four generations of people who didn't have a direct connection to the common sense, long term lasting European buildings. We had a lot of European type builders come here and basically we had to unteach them, we had to teach them this skinny wall construction, build it fast, get out of there, take money and run, and then replace it, every 30, 40, 50 years instead of every several hundred. So yes, it's a cultural thing. It's deeper in America and North America than any other place in the world, although the rest of the world, you know, has adapted to this, this terrible paradigm. So yes.
Uh,
So how do you
uh,
unteach that? It's really
well,
something.
that's your book, and you are doing that. But the question is that it has to be received and delivered en masse. I want to go to some very practical things right now, having to do with
Sure.
people using air conditioning units in their home, apartment, condo, wherever they live.
Mm.
When you change the filter of, you have to change your filters every few months. What are most
Sure.
people using?
Oh, depends on what unit they bought, but most of them are HEPA filters. So filters have improved quite a bit over the years. And what we do is, of course, we're using mini splits whenever possible because that's creating the heat and cool at the unit and using only a little fan to distribute rather than long ductwork that deionizes the air and becomes, a gigantic source for mold. But we complement those with what are called ERVs, energy recovery ventilators, that stand alone, usually on the opposite end of the room, sucking out and replacing air through these HEPA filters. They're available in every size imaginable, from little $400 units that can handle 400 or 500 square feet, up to whole house units that can do, 8 different rooms constantly, 24/7, replacing the air with filtered air, through the HEPA filters. Some units have up to 7 filters, even being able to filter smoke. You can have a forest fire and have fresh air in your building with, no window open.
That sounds wild. That sounds pretty wild to me.
Yeah, and what's
You,
happened is the reason that's gained a lot of popularity is because so many builders kind of innocently started building these high-end homes super, super tight, and they got in deep, deep trouble. Massive multi-billion-dollar lawsuits for homes that were trapping moisture and terrible indoor air quality. So these, ERVs have kind of come and saved the day. They allow you to have a full, airtight, terrible, long-term, disaster wall, but constantly replacing the air, with well-filtered air, and they are extremely quiet and energy efficient. And because they're not distributing heat and cold, they don't grow mold in their ductwork. So you can even duct them all over the house through these polypropylene food grade, little 3-inch diameter, high pressure ducts that make no sound, that use, like 20 cents of electricity a day to run at,
So
11 cents per kilowatt hour.
let me clarify something with you. When
Uh-huh.
you say ERVs, what is that?
That
I'm
means
not clear.
energy recovery ventilator. So what it's doing is taking in outdoor, is sucking out the bad air inside your house or inside individual rooms or your whole house, and then sucking in new air through a set of filters. Sometimes only one filter, big enough to get things like pollen and air pollution, but not fine particles of things like, smoke and, you know, tiny dangerous particles of other sorts. So it
Where
depends
do you
on the
put it? Where do
anywhere.
they go?
Yeah, you can buy
Are they
individual.
like little air? Are they like little air filtering units?
You
Is that what
can
they
use them
are?
in that way, or they can be whole house units or zones of the house, like groups of 3 or 4 rooms at one end of the building, and then one towards the middle, and one towards the end, like in a large house. So, and every combination is available now. So, you can meet the requirement of the building. I mean, historically, like you lived in Germany, everybody,
Right,
does, they wash their homes with air in the morning. Doesn't matter if it's, minus 10 degrees, you throw the window open for
right.
10 minutes. Everyone
Absolutely,
does
it was
it.
gorgeous. I never felt so good in my life living in any building as in Berlin in
Yes.
Prenzlauer Berg.
Yes.
And I would open
Everybody
the
would
window. It
flush
would be
their building.
snowing outside. Snowing. Oh my God, gorgeous,
Yes.
incredible.
Yeah. Wonderful, wonderful feeling. And of course, now air pollution, and we all know things like just pollen. You can get enough pollen on any surface, even standing clear water can grow mold on it. So, these materials we're using can't become food for mold, but you can get enough slime on them to grow mold anywhere on anything. And we're finding more and more urban environments, well, they can't open the window anymore. That's incredibly sad. We started our business, in the 80s, when a lot of our projects were rural and people would throw their windows open. So, and
That's
I do
true.
that now even. I don't care what it,
Yeah.
and luckily, we got an energy efficient building. It's working out even with windows, even at 100 degrees every day. It's worth it. Because, now I'm in a conventional building that doesn't have the air, and fully why, why we're having to do that more and more, into,
So
mini splits, right? And we'll
people don't
talk
know what
about
a
that a
mini
little
split
bit.
is. Hold on a minute. Go back.
Yeah.
Go back a minute. You're using language most people won't know. What is a mini split? What are you talking
Yeah,
about?
that's those little wall units, and they can even be ducted now, that through a phase change, they have an outdoor compressor, and the really high level ones, are called ground source heat pumps. And they have great big coils that go like, 10, 20 feet into the ground and extract the temperature of the earth 10, 15 feet down and compress that into a compressor, and then do a phase change with this compressed air through these tiny little tubes that go into these little units that, kind of look like baseboard heaters, except they're usually, like above a door. And they're both
Mm-hmm.
heat and cool, but it's created at the unit, which is a big deal. There's no ductwork between And the modern ones, the more common ones now, are just, the outdoor compressor is just, fed with electricity or gas. And even that combination is so superior to the full whole house ductwork of blowing hot and cold air around the building. That's incredibly unhealthy, cold air and warm air being thrown on your body, right? And it's medically criminal. It actually is.
So I want to ask you something about the building codes. Now, specific to what you're talking about right now, is it okay to build a structure without those ducts? Let's say you're going to. Do you
Yes.
have to have duct work? Is it
No,
okay
you
to have
don't.
not?
No. Yes, you can even.
No, what? Be clear.
You
Be
can-
clear. Hold on. Go back.
What do you want me to say? Of course,
No. What I'm
you
saying.
can put in
Yeah, what I'm.
radiant heat, and
Yes.
that's all that's required by building codes. You don't even
Okay,
have to
that's
have
clear.
AC. Right. We all want
That's
it.
what I'm asking you. Yeah.
Yeah. And so we've done extremely efficient homes, with this Baswell and NextChem and Hable, and we'll put in like little $40 baseboard electric heaters, which are fine if you never turn them on. They're extremely inefficient, and you don't need them if you design the envelope properly. Some of our buildings have 7-foot eaves. We have cold water misting on tile roofs and cool towers up the center. All the old strategies that the people had to do before the days of AC. In fact, where we live here in Central Texas, this area was considered uninhabitable until about 1955, when widespread use of AC came about. Well, it turns out there were German villages surrounding us, like Fredericksburg, with fantastic double wall stone buildings that heat and cooled themselves perfectly from about the 1850s up until 1955, where they started to throw in the AC and heating units. In other words, it's all a myth. Right. All of this expense that we're doing on these central heating and cooling, the majority of it can be handled passively through good building envelope design. But for some reason, this whole thin wall thing took over because they could mass produce it so quickly and just throw in a little mechanical piece and pretend it was working. And you bring up a really good point about what we call psychological heat and cold. That's where you push the button and you feel the cold. You push the button, you feel the heat. That's throwing hot and cold air on the human body. It's not what your body needs. You need the thermal storage of your bones to be conditioned so you can walk in and out of that building at 100 degrees or minus 10 and not get sick by the shock. In other words, your core is balancing you out. And you don't even measure the air temperature inside the rooms because you feel fantastic.
Can you talk a little bit about the role of fiberglass and how some of us are able to add or subtract fiberglass from air conditioning units, and talk about fiberglass and some of the dangers of the fiberglass in combination with the AC units? That was very, very, oh my God.
Yeah, the filters were all made with that pink fiberglass for a long, long time. Now almost none of them are. Everyone's caught on. They never worked because they were always damp and they didn't filter well at all. So,
what about the old units? Like, I'm in a place with an old unit, 18-year-old unit. Even though it's a beautiful house,
you can replace the filters often, and most of them are not fiberglass anymore. If they are, they're versions that have resolved a lot of their water retention qualities. In other words, you can fluff up fiberglass enough to make it give up its moisture a lot better. So the new filters are, much, much better than in the past. It's always good to super replace those as much as you can. But now we're only air conditioning. We're not thermal mass charging, which is exactly what we should be doing in our house. Balance our core temperature of our body to pump blood properly, to get our brains functioning right.
So how
So,
would that be done? If you own your own home, what would you do? We're going to go to the
all
three
you
different
can do,
examples.
yeah, if you're kind of stuck and you can't replace your heating and cooling system, then of course, you start with getting as many of the interior pollutants, but they're minor compared to the mass of your wall. The average home has 30,000 pounds of drywall, 70,000 pounds of plywood or particle board. That's where that's what's infecting your body the most, not the tablecloth in your, dining room table. Although that ideally would be non-toxic as well. So most people start on the inside and get as many interior pollutants out as they can, clean bed sheets and even the paint will really, really help. If you can get all mineral paint, and we work with these wonderful, Italian group that's now the fastest growing paint company in America, this Roma Bio potassium silicate, 400-year-old reputation.
Fantastic. Oh my
Yeah,
God. I've seen it in action and worked with it.
yeah.
Very,
That's
very,
something you
very
can
impressed.
do
It's a
right
big
away.
wow.
Right. At almost the identical cost. It's like $50 a gallon. But the fake zero VOC paints, which are all petroleum based, all trap moisture and quit breathing after 5-10 years and trap more and more moisture as they get older and older and multiple layers get built up on the wall. But they make this wonderful product called BioGrip by Roma Bio that will actually etch into the multiple layers of latex, which is a polymer, derived from the waste products of petroleum, and force the outer layer of your drywall, the terrible paper, to breathe. And yes, it will stop visual mold on the outside of your wall. It means all the bad things are still happening behind it, but they're less bad because minute amounts of vapor get through the assembly now, even with fiberglass insulation. Sometimes that's all you need is a very, very small amount to get through to let that cavity hydrate enough to not have the amount of moisture you need to grow mold. Most walls are not doing that. They're holding more than enough moisture to mold. Just a matter of time, that they'll bloom, behind your wall.
I want to talk to you about, I want to stay on this subject of the walls. So if someone's in a position, they have invested in a property and they want to change out the walls, what are they to do?
Well, the ideal
What do they
is,
do?
well, okay. And first we should talk about those who are doing it. And typically they're the ones who learn their lesson. All the mold treatments they did, mold kept coming back, or they replaced their drywall with the same drywall that created it. So ideally, they're at the point they know the damn drywall's got to come off. It's food for mold. When it's wet long enough, it actually becomes food for mold. It's got to go. It never was the right material to put on the wall. So you get that off. You wipe everything down with hydrogen peroxide, only 3 to 5%, so it doesn't eat up your fingernails. And you get what we call the construction slime off the wood framing. And when you open the wall, you'll almost always find either plywood or particle board as that outside layer. And obviously the pink insulation's got to go. It'll be so obvious when you open the wall. there'll be black particles all over it, 100% of the time.
Right.
Yeah, so it's got to go. And then you wipe everything down, and you use old rags that you throw away because you'll never get that mold back off of anything that touches it. And then we spray it with a blend of magnesium oxide and potassium silicate and superfine clays. Turns out those 3 or 4 minerals are the primary minerals that are missing from modern forest-grown lumber. For the last 80 years, we've had lumber that's been forest-grown 10 to 15 years instead of 50, and it's missing the essential minerals that have everything to do with this phenomena of converting moisture to vapor. And the best analogy we can use is in the human body. Bone next to tissue, which is analogous to clay next to cellulose. It has the same electronic signature as clay and cellulose. Push next to pull creates a push-pull electromagnetic dynamic in your body that extracts 2 quarts of water a day and you're not wet. If your walls were doing that, they would last for multiple hundreds of years, and they're not. So we've come up with a way of, teaching the walls how to breathe. We get the minerals back into the wood. We get the insulation replaced with, at minimum, rock wool. Rock wool isn't perfect. Got 0.5% natural formaldehyde, less formaldehyde than even the wood has naturally. So most people can handle it, and it's at all the big box stores now. It's taking over finally. And then we get rid of the drywall and we put these magnesium boards on. They've been used worldwide. It's a world standard, in fact. China banned our plywood, OSB, and our gypsum-based drywall over 20 years ago. Not one announcement was made in America. And in that 20-some-odd year period, they built 70% of the world's construction without our plywood, OSB, and drywall. We don't need it. It all traps moisture and emits poison and becomes superconductive when it's wet. It's the definition of mold. They got to go. So the best we can do for the sheeting that's already on the outside of the building is to get these minerals, even back into the terrible OSB. That's orientated strand board, the chipboard that's just packed with formaldehyde, toxic glues, all developed by Dow and DuPont, all of it trapping moisture from day one. And plywood's not much better. It's got 5 to 7 layers of glues based on the waste products of the production of petroleum that are fully toxic, especially when they're wet. They're outgassing into your wall cavity and promoting things like mold because they're holding moisture. So you get all that kind of resolved. You get this clean mineral wall board, ceramic board onto the wall, and then all potassium silicate mineral finishes, including the joint compounds. We have all natural compounds for all of that. And what we do for clients is we line up these materials. We figure out the amounts of them they need. We do all the logistics to get these onto people's job sites because none of it's at Home Depot. But during the COVID period, the use of these materials, over doubled. None of them went up in price more than 30 to 40%. And the average conventional material doubled, tripled, and quadrupled over the last 5 years.
I remember
Yes.
going into Home Depot in shock.
Shock. Total shock. Yes. So now, like our magnesium boards, which are fully structural, are slightly less than the equivalent plywood. And they have all the structural ratings. There's about 17 outlets for the board across the U.S. now. When I started this, back in the early and even mid 80s, there was 1 or 2 groups bringing it in. So even the large distributors like Huber, the largest material distributor in Europe, is now stocking a magnesium board in 17 locations throughout the U.S.
It's
So times
fantastic.
have changed.
Fantastic.
Yeah. So, this is much, much better times now because COVID kind of opened it up. When the CDC admitted that a full 93% of those who died from COVID had compromised respiratory and immune systems. That's what
What
these toxins are about.
I want to go to, I'm going to ask you a very uncommon question.
Uh-huh.
And that is for those people that are watching solar cycles who are aware of the grand solar minimum, which is a cycle that repeats in the same way warming does, cooling does. It's coming up between 2030 and 2032. And in my interview with Dr. Valentina Sarkova, she talked about the impacts of the grand solar minimum and its role in dire cold, changing environments, etc. So for those people who are aware of this and would like to prepare their environments if they can, how would you suggest people that are ready to invest in their environments to block dire cold?
Oh, of course.
What would you suggest? Let's take 5 minutes. I want you to guide them what to do.
Sure, you'd have a minimum 12-inch deep wall with isolated mass to the inside that you can charge with this radiant cool or radiant heat. That again, you charge for 20 minutes in the morning, turn it off, and 7 hours later, you're getting it free 500 years from now. This is a physical phenomena, and that's that long wave going into your bones because you're not going to be able to heat or cool the air under these severe conditions.
Right. There will be no electricity available that will work in traditional solar panels, electric cars, etc. So all of that won't work. So if all of that won't work, then what are people doing?
Yeah, then for charging your building, fire, sun, or hot water. Now, fire, obviously has worked for centuries. It works incredibly well inside of these thermal mass, Faswall, NextChem, Havel kinds of buildings. So in other words, our very favorite is vertical log burners, where they burn these anywhere from 4 to 7, 8-inch diameter log from the bottom up. They burn real slow, but super, super even heat. There's fantastic units out there that distribute that, naturally. It's a long wave. It cuts through the air, So yes, there's a lot of layout work that we do on the buildings to promote this natural transfer of light, heat, and sound through the building. In the ancient Vastu, it was called the Brahmastan, the little central area that had the cupola above it that mixed everything by natural pressure of the heat up towards the cupola, sucking from all over the perimeter of the building. Now, those criteria were made at a time when you could open a window and even crack a window and create these traps. In some of our earliest buildings, we'd actually pump colored smoke into a building to show how these currents move. And historically, that was done by having, gaps under your door and a gap and transoms above the doors to the adjacent rooms. So you could get these movements without ductwork. And that's ultimately where we'll go back to when we don't have heat, cool to waste. Now, we talked a little bit about the ground source heat pumps, and they minimize the amount of heating that you need to do to the hot water that's been preconditioned by circulating in these big copper tubes, 10, 15 feet down. Even 3 feet down, the earth temperature is stable at 55 degrees and like 80% of the entire planet. So we're going to have to use a lot of those types of strategies in the future. But, we always tell people build the envelope as if all of these things are happening, either severe cold or severe heat. They work, we've got these buildings in Alaska, Hawaii, it doesn't matter. The biggest use of this material, of course, well, Germany, this type of material has been, the number one building system for over 50 years. But places like Canada, have been making this block for close to 100 years. They do about 10 times more of it than we do because of their severe northern climate. These blocks are perfect for that. You need heat and cool that was made efficiently in those conditions. So yes, here in Austin, we can get away with a 2x4 building and opening our windows, and we don't even have weather. I lived in central Iowa for 15 years. That had weather, and we did a lot of the thermal mass buildings. We did a lot of thermal mass basements with this, but utterly and totally comfortable spaces. So, and again, it was only that dire need that woke people up, or like now I work with people with, the dire health needs. They get it after building 4 or 5, $1 million plus tight green buildings. They got sicker and sicker in every building they built in. And then they finally get it. But usually they get it by traveling to Europe, or they have friends who live in Germany, Switzerland, Norway.
Right. I mean, that is the way is by having that's the way is by having experienced the difference. I want to go back. Take you back a little bit to that project that I worked on in not Los Angeles. My God, I had too many years there. In Charlotte, there was under basement in the basement or under the house. There was mold. Okay.
Of course.
And I had called in this company. in the traditional way, the best of a certain paradigm. And I should qualify by saying in a certain paradigm. And they gave a quote of like $30,000 to $35,000 and all this and all this stuff. And then, ladies and gentlemen, I called George and I said, "What is this? What are they doing?" Do you remember? I want you to explain to the public the distinction. This is an example of you can go to the best of a wrong paradigm. Talk about it.
Yes. Their paradigm was to seal that space, thinking they could get every tiny little crevice foamed up, sealed, and let it all die underneath. In other words, they put this heavy 20 mil plastic down. They foam it onto all the posts, so there's not the tiniest gap that can be perceived. By the way, it'll all shake loose in 10 years anyway. The nature is going to win. You can't just kill something by throwing a thick mat on top of it, right? And that's a very, very sad paradigm. But that temporarily, that will work. That'll get them through their warranty period. Maybe
and
3-4
fans,
years.
Right? And they were putting fans where the air could blow out the side of the building. Remember that?
The fan?
I think a fan. A fan.
Oh, fan.
To blow the air. A blower to blow the.
Yeah. They were sucking air out of it. They probably were using, basically they're creating the crawl space into full conditioned space. And we agree with that. You can do that. But we don't agree with trying to seal the earth underneath it. Better to, pick out 4 inches of the soil will have mold in it on the top every time. And they should measure that. When they measure mold counts for the building, they should take the soil samples of the crawl space. They rarely do, but you ask for that. And you take that 4 or 5 inches off. We replace it with earth, clean, sandy loam that's got 15 to 20% magnesium powder filled into it. That gives it all the antibacterial. You're letting the earth breathe. And we are putting the air exchangers into the crawl spaces. Typically, we seal up, the perimeter and only bring in clear, clean, filtered air into that space. In Florida, we have to complement that with, I hate to say it, dehumidifiers as well. And that's burning a lot of energy, but that's what you got to do when, you have extreme humidity combined with foul air, air that's, recirculating the full, off the earth. So yes, it's almost sad because we've created every one of the problems and now we've got to, remediate these. But it is all about getting clean air exchange down there. That's number one. And in most climates, like North Carolina, because we're doing several projects there, we can do it with just the ERV, the energy recovery ventilators that we talked about. That's enough in the crawl space and the attic. Real often, that's the second place, growing mold is up in the attic, and we get those air exchanges. In those small spaces, like a crawl space, only 2 feet high, that can be handled with a $400 or $600 unit. And then again, that's running 24/7, constantly replacing the air and bringing in the clean filtered air. So,
But
and that
the
costs a whole
the
lot less
different.
than
Well, I
ceiling.
mean, what was it like 6,000 compared to 30 to 35,000? It was a whole different application of body of work, the
Correct.
labor, the whole
Yes.
bit, and the application of preparing it to be gone was totally different. Totally.
Yeah. You can't seal the earth. It doesn't ever work out in your favor, and that's why we do a lot of mitigation on people's slabs. We have what we call the drainable, breathable slab. How not to use those crazy vapor barriers that always grow mold under your concrete slab. Because, the biggest negative, there's huge negatives related to concrete. Baked at 2,800 degrees for 8 hours. It's physically sucking charges out of your tissue. And our book goes into that a bit, but we don't want to get into that too deep because that's considered, just too far out. What we do want to do is get the moisture back out of your slab. So, we have a protocol in the book on how to use filter cloth instead of vapor barriers, allow it to breathe, and put a 3-4 inches of clean river rock or crushed windshield glass, or even these Faswall chips underneath for insulation that can breathe, that allow moisture to pass through by gravity and suck out the edge of the perimeter of the foundation. So, that's something that's being much more broadly recognized. It's been done that way in Europe for at least 150 years. But somehow our code's got this thing of create this vapor barrier so water can never come from the bottom and suck up into your slab. No, by gravity, water wants to fall down. If you are in an area with a constantly changing, groundwater sucking up, you shouldn't be building there anyway. You should build up higher. It's a wrong spot on the lot to build. Or, go ahead and use that vapor barrier, but then still have the rock pile, clean rock pile with filter paper on all sides of it to give a drain away before the water sucks up to the top of your concrete. By the way, that's extremely rare, so most buildings can get away with just getting rid of that crazy vapor barrier. And, back in the 70s, I worked for a demolition company for a while, and every single slab we chipped into to take the slab away, had mold on both sides of that crazy vapor barrier. There was no place for
Very
the moisture to
interesting.
go. It bled.
Wow.
Yeah. So a good 3/4 of all our homes have mold underneath the slab, and that is coming up through the cracks. And that relates to this whole, concrete sickness is called, and it's prevalent. It's all over the place, and that's the hardest one to deal with. you know, but things like the ways they deal with radon, they come in and they'll dig veins into your concrete, costs a lot of money, ship in there, or, foot wide, fill it with gravel, filter paper, get pipes with little holes in them, in other words, flush it. And that'll help a lot. That'll also, remediate radon. So yes, and people do have to go through those rough things when the radon level is so high. But even radon needs a wet, cold, damp, bleeding environment, to thrive in.
Would you replace concrete if you could, and
Yes,
have
and we
people
have. We've
like their
done a couple
driveways? What would
slabs
you
with
do? What would you do?
Yes, it costs a fortune.
What would you do?
Yes,
Yeah,
we've
what would you
done
do?
2 of these all magnesium oxide slabs. The raw material in America is 12 times the cost of the raw material in China, where it's ubiquitous. For 5,000 years, China used magnesium oxide for their cement, for all their temples and monasteries. And those places have no mold, by the way. And it was
I
the
believe
world's
it.
concrete in India and in Magnesia, Rome, the Parthenon. So a lot of those blends we don't even know how to do anymore. China is very, very close to reproducing all the ancient blends because they have this massive, rebuilding of the temples and monasteries in China, actually the biggest restoration program in world history. You hear nothing about it in America, but it's been very, very helpful for their tourist trade, to restore these buildings with the ancient materials. And
I want to
China
ask you
gets it.
something
They
that's
know
just
they
a.
have to reduce the number of toxic products they make for Europe and America. There is no choice
Um,
in China.
well, I mean, China has other challenges, right? They do some incredible things with health and wellness and the meridian system and the. I don't know if you studied the I Ching, but it's something I studied for years and used and loved.
Uh-huh. Yeah,
And
it's wonderful.
but
Yes.
But I wanted to ask you on page 49 of your book, you said here, contrary to the claims of some firms marketing far infrared saunas, that their
Oh
rays are
yeah,
deeply
that's a little bit
penetrating.
controversial. Right. In
I
fact,
know, but that's
Dr.
why but
McCullough,
I wanted to
went
ask you.
through a massive lawsuit on it all. And yeah, all that was pointing out is, especially at the time of the book,
But
2008.
wait, wait, before you go into it, hold on a minute here. I wasn't done. We have to talk not to me, to the audience. So let me finish what I was saying so they understand
Oh,
what you're going to be
context.
responding
Sure.
to.
Uh-huh.
Yes. Contrary to the claims of some firms marketing far infrared saunas that their rays are deeply penetrating, the scientific research we found indicates that for the most part, these longer wavelengths only penetrate into the human body about a tenth of a millimeter due to strong optical absorption by water reaching the epidural layers only and not the deeper dermis.
Uh-huh.
Okay, that's on page 49. So, did you want to respond to that? I
Well,
just
yeah,
thought it was
just a little
interesting.
bit because, right, that's what, Dr. McCullough went through a massive lawsuit, based on this, assumption that these infrareds were going to, get deep into your bone mass. Well, they don't automatically. In other words, a lot of the units that were being advertised, simply didn't. But they were all using the assumption that infrared light was penetrating straight through our tissue and bone, all that, and straight into our bone mass, which would have been wonderful. And even saunas, to a degree, do that, but they don't do it the same way as this long wave sun, fire, or hot water does cut through that. And infrared light combined with sunlight will do it. And there are infrared units now that, simulate true sunlight, much, much better now than in the past. And a lot of that's
Is it
actually been
infrared?
resolved. There are units.
Is it
that,
infrared or far infrared that have improved and are now can get to our bones?
Yeah, and I don't know. If you really
Okay.
want to
Okay.
look into it deeply, you would go to Dr. McCullough's website, because he was forced, based on, extreme lawsuits, to defend this. And I think he had a lot to do with how to distinguish between the good units and the ones that can do it and the ones that can't. But a large
Yep.
number of the, I guess you would say, the affordable units, simply weren't
Yeah.
penetrating. Yeah, and that, it's
Sure. No,
understandable.
thank you.
They did what they had to do to make money.
Understood. I just thought it was interesting because people are into these saunas and these
Yeah, and some of them are
they've
working
become
incredibly
big.
well. And Mercola
Yeah.
kind of outlined the whole criteria for, judging good infrared and, infrared that was, more superficial.
I want to give some tips as I want to talk about uh, electromagnetic radiation. But before we get to that, can we give the listeners some tips what they can do in the right now if they're not purchasing new properties and they're not going to do a whole infrastructure change? Are there some little things they can do that are still very important and helpful?
Well, yes, obviously the painting is actually a pretty big deal, because that is affordable, especially if they were already considering using, zero VOC paint. Say they've already got in their mind they're going to pay $45, $55 a gallon. Please, for the same money, buy these. They're actually called 100-year paints. They actually prove they improve for their first 100 years of life. They don't quit breathing on you, and you get to move in the day you paint, and the pets won't die and the plants won't wither.
Okay. And is there any
So,
other suggestions in terms of some tips that people
well,
can
for air
use right away?
quality, yeah, a lot of our clients, use like the Air Doctor. That's a super popular one that's quite affordable in the, anywhere from, 200 to $700 units that, can handle pretty much the whole house air filtering. But that doesn't go into what I call the electromagnetics of air. In other words, the radiant versus convection, the wavelengths of the air that, either penetrates your bones or it doesn't. And of course, anything that got blown around through ductwork isn't doing it at all, doing it in the opposite direction. It's, you know, it's hurting you. So, um, ideally, you live in a climate where you don't have to turn on, that crazy, ducted heating and cooling. And of course, ductwork can't be cleaned completely. All those 90-degree edges and corners, are all harboring mold even after you had your ducts cleaned. It's just a terrible method, but it was necessary to figure out an affordable way to, deal with these, skinny little 2x4 walls and windows, poor quality doors and windows. And we can go into that a little bit, but what's great about what's happened with doors and windows is they are available in extreme high quality now, double, triple pane, frames that don't leak anymore, frames that actually have little weep holes to diffuse the moisture in the frames and not rot out the edge of your window frame, and all the things that were happening in the past with the metal frames and all that. But again, those are expensive to do well, but they're replaceable. And the wall you won't replace. So, we should tell people, put in single pane windows, use orange crates for your kitchen cabinets. All of that is replaceable. This wall mass is extremely hard to replace. In fact, you won't, right? Because the building comes down. Can take one wall
Okay.
down at a time. Yeah.
Is there any other tips at the moment that you can share before we
Just
go
for
to the
clean,
electromagnetics?
of course, right? Organic sheets in the bedrooms, you know, household products as non-toxic as possible. There's great websites on how to, blend your own cleaning liquids, that avoid all the commercial stuff. Um, Same with, cosmetic products. There's clean ones out there now. They do tend to be higher priced. Best to learn how not to do it. Like, 20 years ago, I learned how to just quit using hair shampoo. You use the oils in your hair and rub them and rinse it incredibly well. And after a month or so, it all balances out. You just stop doing
Good luck
it.
talking to women like that, George. That's a more of a an understanding I think a lot more men would appreciate than women. But
Right,
that's my
right.
take on
Yeah,
that.
yeah,
Yeah.
because you want that
Shall we?
soft, fluffy right away.
Shall we? Yeah, really. Shall we cut? Shall we cut right over to electromagnetics? Let's talk
Yes,
about it.
which are
We
much,
have about
much, much.
10 minutes left. This is a long form today. Let's talk about the electromagnetics. Now, I've interviewed some of the most remarkable people in the electromagnetic spectrum on what's
Yes.
happening. But let's talk about electromagnetic radiation in the context of building materials and what you have to say about
Envelopes
that.
of buildings. What conducts and what doesn't. What things conduct, dry things are less conductive. So yes, modern building envelopes that are with pink insulation and regular drywall and 3 layers of plastic paints um, are highly, highly conductive to EMFs. They're simply wet. So yes, getting the moisture out is number one. So I work with a lot of people who spend a lot of money on, especially high level homes, to remediate all their EMF issues. And yes, you can get your EMF count way, way down, and 100% of those people then discover, and I could tell them in advance, you are also chemically sensitive. The EMFs were simply more painful than what you experienced when you got rid of them. You then felt what's inside of your wall. We like to start with that wall and work back, because it turns out these, especially like the magnesium oxide alone, can it alone just a half inch will cut 60 to 70% of the EMFs coming in the building, and you can enhance that all the way to 100% with the right graphene mineral coatings on it.
But I want to go back when you say that the magnesium oxide walls, right, the half inch, can
Uh-huh.
block about 60% of electromagnetic frequencies coming in. It
Yeah, from a
sounds to
cell tower,
me
for example. Yeah.
from a cell tower, right? It
Uh-huh.
sounds to
Microwave.
me, yeah, like a kind of Faraday cage effect. Obviously, not a full Faraday cage, but people don't realize that these electromagnetic frequencies are coming in through walls. They penetrate everything, windows,
Correct.
ceilings, everything. So if you're doing the work on the walls and you're putting a half inch of magnesium oxide board all over the place, then what? I mean, is that also on the ceilings as well?
Of course. Yes. Yes.
Okay.
Every
So
place
it's
you would
everything.
have used either plywood, particle board, or drywall, gets these, clean materials. Now we enhance that quite a bit by using the potassium silicate mineral finishes, because they're also converting moisture to vapor all day long. They're sucking water out of the wall for you and converting it to vapor to let it blow off in a safe form without making watermarks on your wall. Just like, the body's getting rid of those 2 quarts of water, and you got, most of the time no water on your skin. So that phenomena that needs to be studied in much, much more detail, and that's what the building biology PhD level programs go very deep into, and make that the criteria for the competency of what you're putting, on your walls or on your skin or on your bed sheets, or the abilities to convert moisture or sweat from the human body even into vapor and allow it to blow off. And none of the things we're doing work. Everything that's bonded with the waste products of the production of petroleum, which is 85% of the products at Home Depot, for example, can't do it. The way they're bonded together violates these fundamental laws of how moisture converts to vapor and passes through. In other words, processes. And that's what we try to do, like in those crawl spaces. We process the dirt. We don't try to seal the top of it.
I bet there, in that context, there's got to be very few people who know how to do what you're talking about in the crawl spaces. Like
Yeah,
I
now
was hard
luckily, right,
pressed.
because I'm consulting a lot of projects in Florida, especially right now. And yes, I send all the specs over. And people have been pretty good about following them because they know the alternative is so bad. If they go in for the, sealing the whole bottom floor of their crawl space or trying to seal off like their entire basement. And all you do is, push that moisture to another location until it moves around and finds, even a pinhole big enough to get in. In building biology, they have a wonderful saying: you can't seal anything on a job site. You can only make the hole so small it comes out with a vengeance. In other words, it's going to rot and mold and come apart on you. So, right, you create millions of teeny, teeny holes, too small for moisture to pass through, and they're called vapor retarders, not vapor barriers. So even the silver linings, the aluminum lining they put up in attics, for radiant barriers, they now have tiny holes in them. Because the other guys all got sued, for molding out people's attics.
Very, very interesting. How do
Yeah,
people get in touch? How do people get in touch with you, George?
well, through our website or through just GeoSwan, www.geoswan, GeoSwan.com, or they can go directly to the building biology website, and that's buildingbiologyinstitute.org. And, there's write up on what we do in there. They have a whole section called, find an expert. And, what's happened in building biology is the vast majority of the young people getting certified in it, go into EMF remediation because it's a hot topic. And there's instruments where they can go in just an hour or two, analyze your home, make, $300 to $800 and go to the next home. And hopefully give them a whole set of recommendations. A lot of them will be similar to what we do. We just take it much further because the majority of my clients, have full on multiple chemical sensitivity. They're at the point in their lives where it's life or death. They came to the point where nothing worked. And they all wish they had done this 20 years earlier, before they built two or three homes that made them sicker and sicker. And these are people with money. People without money, it's incredibly difficult. But we have done, projects for people like converting cargo trailers, where, for a little $6,000-7,000, cargo trailer, not travel trailer. Of course, the regular trailers are just terrible. But you can get these travel trailers. Typically, all only have one window and one door, and we work with a few manufacturers that will at least take out the plywood on the floor. That gets replaced with 3/4 inch magnesium ceramic board, and then we line the inside with even 1/8 MgO. And typically we'll fur out, because they're only an inch thick, little metal every 16 inches on center, and we'll fur that out so they can get at least 3 inches of real rock wool in there, and then the MgO board, and then the natural finishes. And yes, then they can survive. They could get a tiny, portable radiant heater in there and get through a winter. So but even then, the grand total, you're going to be up to $20,000. But in terms of what buildings it cost, that's
And did you say that's a
1/100th
cargo
total
trailer, or
cost now.
that's a travel? Is that a cargo trailer or a travel trailer you were just referring
A
to?
cargo trailer. Yeah,
Okay.
they're the cleanest out there, right? Because obviously the normal trailers are just packed with everything, the worst possible, for a person with these chemical sensitivities. So we can get that little,
Well,
cargo trailer, low EMF, um, clean chemically inside, but they have to leave the trailer to go to the bathroom and cook, so they have to have an adjacent home nearby. But that's for our most severe. These are the clients that are already, living in cars and in tents. And there's hundreds of those people out there now. And, that's the hardest group to work with, obviously, even coming up with the 20,000, which of course in today's cost is, equivalent to 5,000, 10 years ago.
right. Well, I want to thank you for all the work that you're doing. And every time I speak with you, it's an incredible learning experience. And it is so fascinating, building biology. And it's so shocking that most of the buildings in the United States are absolutely suited, diametrically opposite to everything building biology is about. And I hope for those people that are interested in some of the things that George is bringing forth, and I want to recommend you all pick up Breathing Walls, a biological approach to healthy building envelope design and construction by George Swanson, or Miller and Wayne Federer as an editor. This needs to be centrally available in all the schools not only in the United States, in the world. George, thank you so much for being on the show.
And thank you very much.
It's Rainmaking time. Bye-bye.